Some people claim that the Indus Valley Script is just a bunch of meaningless symbols, not a real language. Today, we are going to dive into this topic using science and some math, and well, mostly math, to show that the Indus Valley Script was indeed used to write a very real language by very real people. Let's get started. But first, we need to explore some language properties. For that, let's meet George Zipf. I believe that's how you pronounce his name. Zipf, as his name suggests, is famous for Zipf's law. But what exactly is Zipf's law, and why is it important for our discussion? The is the most frequently used word in English language. The second most common word of appears about half as often as the. The third and shows up roughly 1/3 as often, and the pattern continues. By plotting these word frequencies on a chart, we observe a distinct pattern. This phenomena is known as Zipf's law, and it is not unique to English language. For instance, if we analyze French Wikipedia and chart the word frequencies, we see a similar pattern. It's the same with any other language or any other book. If we take a Spanish language translation of Sherlock Holmes stories, we see the same pattern. When we take the logarithm of these curves, we get a linear pattern. Interestingly, this applies to all languages. They all follow Zipf's law. So what does this have to do with the Indus Valley Script? Well, we are going to test if it also follows Zipf's law. If it does, it's indicative of a real language. If not, well, I might just switch careers and join a bank or something. To begin, I compiled all available data on the Indus Valley Script. After analyzing the frequencies of the symbols, I found the most common word to be the U-shaped symbol, followed by a double sign, and then the well-known fish symbol. The U-shaped symbol appears 1380 times, the double sign 752 times, and the fish 379 times. Plotting these and all the other symbols, we observe the same frequency pattern as in any other language. Logging these frequencies, we get a linear trend, suggesting that the Indus Valley Script behaves like a real language. These results are based on all of the available Indus data, spanning 1000 years. So interestingly, the pattern even holds when analyzing data from different phases of Indus Valley Civilization.
Yeah, Mr. White! Yes, science!
To those doubting the linguistic nature of the Indus Script, here is your answer. But we are not stopping here. We will use another tool to support our claim, the entropy. Entropy measures randomness. In simple terms, it is the amount of information needed to represent a given amount of data. Highly random data, like white noise, have very high entropy, while a box of identical red balls has very low entropy. Languages tend to fall in between, showing patterns that are neither completely random nor entirely constant. Languages are very deterministic. Here is a graph showing the conditional entropy of DNA. For comparison, here is what English language looks like. Let's throw in Tamil for good measure as well. And when we plot Indus Valley Script in here, it again scores in a range indicative of a real language. All the data I have used in this analysis is linked in the description below. Thank you for watching and see you next time.